Our topic today is laws of motion. ओके ये तो सबने सुना ही होगा. अपने पास न्यूटन बाबा ने निकाले थे टोटल 3 लॉज ऑफ मोशन. ओके, बट न्यूटन को ये 3 लॉज निकालने के लिए आइडिया कहाँ से आया? तो बेसिक ये जो जनरल आइडिया है न्यूटन का 3 लॉज ऑफ मोशन, इट केम फ्रॉम गैलीलियो. Okay, so what Galileo understood about regarding motion was, okay, he did an experiment, okay, wherein he released a marble ball from an inclined plane from a certain height. Okay, so this we have a certain height and this is our inclined plane. Okay, so what Galileo deduced in this motion law was, when this marble was released from this certain height, okay, on this inclined plane, and then there was another inclined plane at a different angle. Okay, so what he observed was, assuming that the friction of this inclined plane is 0, the ball will reach the same height h from where it was released, okay, and then stop at that position. Okay, so this was Galileo's law of motion, which he observed previously, and using this law of motion, Newton proposed his 3 laws of motion. So can you guys tell me what's the first law of motion? So Newton's first law stated that if an object is in the state of rest, okay, for example, if we are standing, okay, we will keep on standing. Or let's suppose an object A is placed on a surface on earth, it will stay in that position unless and until there is an external force. External force, okay, when an external force is applied, till then the object stays in the position of rest, okay, or the object will continue in its state of motion. Okay, it will keep on moving, okay, until and unless there is an external force that is applied on that object. Okay, so I hope everyone understood this. This law of motion is also called as law of inertia. Okay, now what does this law of inertia exactly means is that object will resist its state of motion. That means whenever, if an object is in the state of rest, okay, if an object is at rest, it wants to be at rest, okay, it will continue to be at rest till an external force is applied, or an object will continue in the state of motion until and unless external force is applied. For example, we throw a ball, until and unless we catch the ball will keep on moving. Okay, for example, we roll the ball on the surface and the surface is frictionless. The ball will keep on moving on the surface unless and until we catch that ball, okay, or any other, there is a wall that will stop this motion of the ball. Okay, this wall will nothing but act as an external force that is going to stop this motion of the ball. Okay, I hope everyone got this. Okay.
Now let's look into some of the applications. Case 1, you are traveling by a car in a straight road. When you take a right or left turn, you are pushed away in a direction opposite to the direction of the turn. This is because your body, which is moving in a straight line along with the car, tends to move in the same direction even when your car takes a turn. The resulting centrifugal force acting upon the car and your body moving along the curved path pushes you away for the course of motion. Case 2. Do you know why you should wear seat belts while driving? Imagine that you are driving a car without wearing the seat belt. Now you apply a sudden brake or hit another vehicle. Your body, which was in continuous motion along with the car, tries to be the same even after your car has come to a halt. So you will end up hitting the steering wheel of your car, injuring yourself. When you wear the seat belt, it arrests your forward motion and reduces the chances of injury. This is the same reason why you fall down from a treadmill when it suddenly stops. Case 3. Shaking a bottle of ketchup. Since the ketchup has high viscosity, it tends to stick to the bottle. Hence, when you append a bottle of ketchup, it simply won't come out. When you shake the bottle, the ketchup, which is stagnant, comes out because of application of an external force. Case 4. Let's try this fun exercise. Take a glass. Place a card on top of it. And then place some coins on the card. Now, remove the card as quickly as you can. The penny, instead of coming along with the card, falls straight into the glass, because of inertia. Don't ever forget to wear your seat belt while driving. If you know any other interesting applications of Newton's first law, leave it in the comments section.
Now, moving on, we'll understand what exactly is Newton's second law of motion is. Okay, now Newton's second law of motion states that rate of change of momentum is directly proportional to the force acting on that object. Okay, so basically it means that momentum is directly proportional to the force acting on the object. Now we are hearing this word as momentum. Now what exactly is momentum? Momentum is written as P, and it is nothing but an object's mass and the velocity with which it is moving. Okay, so an object which is moving has a certain amount of momentum because it has its own mass and it has its velocity. Okay, इसका मतलब अपन क्या समझते हैं, अगर मास ऑब्जेक्ट का ज़्यादा है या फिर वेलोसिटी ज़्यादा है, दोनों में से कुछ भी एक ज़्यादा है या दोनों ही ज़्यादा है, तो वो ऑब्जेक्ट का मोमेंटम जो है ना वो बहुत ज़्यादा है. ओके, आई होप एवरीवन इज अंडरस्टैंडिंग दिस. इसका मतलब बेसिकली क्या हुआ, अगर अपन ज़्यादा मोमेंटम से फेंकते, फॉर एग्जांपल क्रिकेट में अगर बॉलर ज़्यादा स्पीड से बॉल डालता है, ओके, उसका मतलब बेसिकली मास बॉल का तो सेम रहने वाला है पूरे इन द मैच, बट द वेलोसिटी इज फॉर अ फास्ट पेस बॉलर इज हाई. इसका मतलब वो बॉलर का बॉल जो है उसका मोमेंटम ज़्यादा है बिकॉज इट्स वेलोसिटी इज हाई. ओके, नाउ मूविंग ऑन, अंडरस्टैंडिंग द सेकेंड लॉ ऑफ मोशन. दिस मोमेंटम, रेट ऑफ चेंज ऑफ मोमेंटम, मतलब एक ऑब्जेक्ट है उसका मोमेंटम क्या हो रहा है, बदल रहा है. ओके, नाउ दिस इज रेट ऑफ चेंज ऑफ मोमेंटम. ओके, उसका मोमेंटम, एक इनिशियल मोमेंटम कुछ और था और फाइनल मोमेंटम कुछ और है ओवर इट्स पीरियड ऑफ मोशन, इज डायरेक्टली प्रोपोर्शनल टू द फोर्स एक्टिंग ऑन द ऑब्जेक्ट. मतलब क्या हो रहा है कि ये रेट ऑफ चेंज ऑफ मोमेंटम जो हो रहा है ये बेसिकली इट इज हैपनिंग because there is an external force that is continuously acting on the object. Okay, now इसको अपन थोड़ा डेरिवेशन के फॉर्म में समझेंगे. Okay, इसका डेरिवेशन समझेंगे. Now rate of change of momentum, okay, is directly proportional to the force. Now force is written as F. force is written as F, okay, and rate of change of momentum is nothing but final momentum minus initial momentum. जो object का motion है, for example, this ball is falling from a certain height. Okay, now this motion, okay, now this ball had a certain initial velocity, and when this object reached the ground, it had a certain velocity, also called as final velocity. Okay, now this whole motion, okay, where the momentum of this object at this position will be written as P initial, and over here will be P final. Okay, now this will be nothing but our rate of change of momentum. Okay, so this two force is directly proportional to this rate of change of momentum. Okay, I hope everyone is understanding this much. अब क्या करेंगे अपन, ये मोमेंटम का जो वैल्यूज है इसको अपन बदल लेंगे. Pf will be nothing but mass into final velocity, okay, minus mass initial momentum will be mass upon mass into initial velocity. But important चीज ये मत भूलो, this rate of change of momentum का मतलब क्या हुआ, this change in momentum is happening over a period of time. Okay, so this change in momentum from final momentum to initial momentum, this is happening over the period of time. So we will write down this as divide by t. Okay, now since mass in these two terms are common, we will take this out as common object outside, and it's going to be v final velocity minus initial velocity over the period of time. Now what do we know this formula stands as? This formula, that is final velocity minus initial velocity upon time, is the formula for acceleration, okay, or A. So we'll write this down as F is directly proportional to mass into acceleration. Okay, now in order to take this constant of proportionality away and make it an algebraic equation, what we do is, whenever we remove this proportionality symbol, we put a constant. Okay, we always put a constant in the multiple. So constant into mass into acceleration. Okay, now this constant is also written as k into mass into acceleration. So the second law of motion is nothing but force is equal to the constant mass into acceleration.
Bicycle riding can be quoted as an example for this law of motion at work. Your bicycle is the mass. Your leg muscles pushing the pedals of your bicycle is the force. When you push the pedals, your bicycle accelerates. You are increasing the speed of the bicycle by applying force to the pedals. Say you have two identical bicycles. One bicycle has an empty basket in the front. The other bicycle has a basket full of bricks. If you try to ride both the bicycles individually with the exact same force on the pedals, you will be able to accelerate the bike with the empty basket more easily than the bike with the basket full of bricks. The bricks add extra mass to the second bicycle. Hence, you would have to apply more force to the pedals to make the bicycle with bricks in the basket move. Now let's move to space. In rocket propulsion, the force on the rocket is determined by calculating the rate of change of momentum when the fuel is released. During the initial era of rockets, solid fuels were used as propulsion agents. They increased the overall weight of the rocket, reducing the efficiency of the propellant, which is technically called specific impulse. With the advent of liquid fuels that used cryogenic propellant, rockets were able to generate the same thrust using lesser quantities of fuel. This enabled the rockets to travel more distance in space and discover many things about the universe. Now let's enter a cricket stadium. We have seen cricket players lowering their hands while catching a ball. Do you know why? By lowering the hands, players increase the time taken to catch the moving ball. As a result, the rate of change of momentum decreases, and by Newton's second law, the force exerted by the falling ball is reduced. The Indian cricket player MS Dhoni is one of the exceptions who works against this law. He moves his hands towards the ball to reduce the time taken to catch the ball, which makes him the quickest wicket-keeper cricket has ever seen.
So that was all about second law of motion. Now we'll learn about Newton's third law of motion, also the most interesting law of motion. Third law of motion. Okay, I hope ये तो सबको पता ही होगा. Third law of motion. That means whenever there is an action on an object, the object will give out an equal and opposite reaction. Whenever there is an action, there will be an equal and opposite reaction. अब इसको अपन एग्जाम्पल से समझेंगे. फॉर एग्जाम्पल मेरे पास क्या है, एक गन है. Okay, now this gun, I'm firing a bullet. Okay, what happens whenever this bullet is fired? Okay, we will receive some recoil in the gun. Okay, when the bullet is moving forward, there is an equal and opposite reaction on the gun, resulting in the recoil of this gun. Okay, so this is our action, the bullet which is moving forward, whereas the recoil of the gun is our reaction. Okay, understanding another example. Okay, let's assume a rocket, okay, which is about to launch into space. Let's assume this is our SpaceX rocket. Okay, for fun, let Tesla be happy and Elon Musk be happy as well. Okay, so what exactly is happening in this? Okay, the physics behind is, whenever the fuel which is burned is applying the force in the downward direction. Okay, the fuel which is burned applies the force in the downward direction, which results in a reaction resulting in the rocket, okay, moving in the upwards direction. I hope everyone is getting it. The third law of motion is really simple. Okay, that is, whenever there is an action or whenever there is a force is applied in one direction, there will be an opposite reaction. It will always be in the opposite direction.
Swimmers always push the water in the direction opposite to their direction of advancement. The same principle is applicable for boat rowing too, where the oars are moved in the opposite direction. After mastering this technique in swimming, you can try to beat the 28 Olympic medal tally of Michael Phelps. You can see speed limits displayed on the sides of roads. The purpose of this limit is to reduce the probability of mishaps caused by overspeeding vehicles and to minimize damages in case of any accidents. At slower speeds, when you hit an object, the reaction force acts on your vehicle and your body is reduced drastically. For aircraft takeoff, the principle of action and reaction is very important. When aircraft runs in the runway, velocity of the wind hitting the aircraft increases. This wind is deflected downwards due to the action of the airfoil. In reaction, the aircraft is lifted upward. If you know any other interesting examples, leave it in the comments section. Thank you for watching this video.